Okay, and last time we were talking about how we would divide two rational expressions. These are rational expressions. They're not equations because there's no equal sign, right? So we're just simplifying here. We're going to divide. Now, what did you say we should do first whenever we see a problem like this? The first step should be to do what? Factor. So I'm going to factor every polynomial. How would you factor the first one? I'll line up an equal sign too. I'm going to show my work vertically and lining up an equal sign. So the first one, how do we factor it? Nice. The bottom one, denominator. Yes, we call that nice. Difference of two squares. I'm just going to leave it right now a division problem because I want to demonstrate something. How would you factor the top one? Nice. And the denominator here. Two numbers that multiply to 5 and add to negative 6. Minus 5, minus 1. Perfect. Okay, if you look at this, now remember that we think about restrictions on the domain as something that would allow, some number that if I used it would give me 0, right? So right now, what would the numbers that you couldn't use? X can't equal what? 5, negative 5, 1. Okay, now what's going to happen when we divide fractions? What's the idea? How do we divide fractions? We have to, so step 2 is we multiply by the reciprocal. And so I'm going to flip the second fraction. So I have x times x plus 4 over x plus 5, x minus 5, times, when I flip this, I get x minus 5 times x minus 1 in the numerator, and the denominator becomes x plus 4, x minus 4. So what numbers now would give me 0 in the denominator? What else? Should I include more numbers in this list? Yes, so because we flipped it, 4 and negative 4 would also get included in that list. And now I can go ahead and simplify it. How would I simplify? What do I do to simplify? I'm looking for matches, right? This is almost like a memory game. Like, oh, here's a match. That's fun. Here's a match. Okay. Is there anything else that would cancel? I don't think so. So we have x times x minus 1 over x plus 5 times x minus 4. Oops, that's an x. I got ahead of myself. Okay, and then remember, anything that canceled was a restriction on the domain. So here, negative 5 is already obvious. It's implied from the denominator, okay? X can't equal 4 is also implied from the denominator. The things that canceled mean that we need to say x cannot equal, and in WeBWorK you go x, don't you do exclamation point? Equal sign? Yeah. And so here you would say negative 4 since that canceled, positive 5, and then because this flipped, this is the one that got tricky, you would also include 1. Because 1 was originally as part of the domain. I mean, it was part of the restriction on the domain. You see what I'm saying? From the original problem. So one strategy I think would be to list the restrictions and then see which ones you need to, identify when you're putting it into WeBWorK. Any questions on that? So the idea is that whatever started out to be a restriction on the domain and got flipped, it still has to stay a restriction on the domain because it couldn't have been used in the original problem. Okay? You're always flipping the second fraction.